Hello everyone, welcome back to Dragonfly Engineering. So we've had a really busy week this week. Earlier this week, April and I went down to Vandenburg Airforce Base to see a night launch of the Spacex Falcon 9 rocket. But unfortunately, a fog bank came in right at the time of launch. So we got a whole lot of audio and a whole lot of sound experience of the launch itself. But I did clip in some of the official SpaceX feed of that launch. And also, I'd like to introduce our new toy, the Iapetus 2-shot injection molding machine. That came earlier this week, so I've got some footage of the delivery of that machine, and we can take a look at it in more detail. So, hopefully you enjoy the launch and checking out this new machine to Dragonfly Engineering. So we are on our way to Vandenburg Air Force Base to see the SpaceX Falcon 9 launch with the latest batch of Starlink satellites. And Vandenburg is on the Pacific coast in Southern California, north of Los Angeles. The closest town is Lompoc, California. And April's with me, she's driving. And we got Sierra back here as well. Say hello, Sierra. She doesn't like cameras. So here we go. We're about 100 miles away from Vandenburg. Alright, so we're approaching the viewing spot, and it looks like a police blockade ahead, so we may have to just find a parking spot on the side of the road here. Yeah, this is fine. A lot of other people have the same idea to check out the SpaceX launch. Probably good that we got a parking spot when we did, because there's tons of cars basically creating a traffic jam in this country road outside of Vandenburg Air Force Base, and they're all realizing that you can't go any further than where the police blockade is. And more cops. We're probably 3 miles from the launch site itself with lots of cars. Okay, it's recording. So we're testing the FLIR. This is up and down the road.
Wow, FLIR is like the secret weapon here.
Yeah.
Nice. Okay, that's good. Got it.
Woo! All right. You get anything? Booster's gonna come down. Of course, my battery was starting to die right before so I missed the very beginning.
Oh.
But you got it.
I don't know if it recorded audio.
I think the cell phone audio records.
What?
Well, I got the GoPro back there too.
Oh.
It sounded cool. Did you feel it in your chest?
Yeah.
Oh well. So much, yeah, stupid fog bank. Well, that was it. It launched. We were completely fogged in on this Pacific coast, but we did feel the engines in our chest from the rumble of the Falcon 9 taking off, and we saw a general glow over the horizon. That was about it, though. But it was fun. It was cool to come down and check it out. You could definitely feel the sound waves go through your body. Here comes one of the fuel trucks. Air gas. So this is about where the center controller is going to be. And the robot's got to grab here. The position of the robot isn't completely ideal.
No.
I mean, it's ideal for the brake, but it's a little problematic for the molding machine wants to be kind of closer that way, I think.
The movement comes from here, but if the tips down here are shaky down here, it constant up here.
Well, a little bit.
So the closer that you are here, the less shaky the whole thing like it's gonna be for picking.
Yeah.
Reproducible accuracy.
I agree. Yeah. But if you can't reach it without destroying the machine, then.
Well, can't you just move it over a little bit? Like, put the same over to the left?
The robot?
Yeah.
No, it's holding to the floor.
Okay, well then can you
So
put
the one thing that is the hardest to move is the robot. Because I've actually got anchors that go under the floor, under the concrete.
Well, why don't you put the molding film more towards the back?
Yeah, I'm considering that, except the fire marshal may have a problem with egress. I think you need 3.5 or 4 feet so you can run out of here. So the other thought is to spin it around the molding machine, and the operator is here,
Oh, that.
which is more ideal for, I guess, traditional setups if the automation is in this cage. This is there. Right there. Is there any questions on that part? Maybe other. What's up, Bill?
Hey,
Hey, Bill.
hey,
What's up?
It's hot in here.
it's easy. You just attach one of your small robots to the end effector.
That's a good idea, actually.
So then you do a 12-axis robot.
Yeah, I like that. So, yeah, it's 6 feet wide. So 3 feet is kind of like, and I probably
Are
need
you
to
going
reach
to turn
beyond.
all of this into clean space?
I'm not sure yet. Probably not, no.
I love it.
I may wind up just turning the molding machine into a clean room.
Yeah.
But the robot picking stuff is, I don't know, it's all in flux. Because theoretically, I
It's
need,
all in flux except for the 6 tons of equipment that's going to come in here tomorrow morning.
7 a.m. Oh, and it's 12 tons.
12 tons. I'm sorry, I was off by a factor too.
So yeah, we're getting down to the wire. Sorry. The gantry.
So the
will
gantry's
move
got to
around.
come over. So how does the gantry come over, and then the robot moves out of the way? Can the gantry get close to? Oh, it can get close enough.
Yeah, I can move the robot wherever.
I put the operator over here.
That's what I'm thinking. The thing is, fire. You need what, like 3 feet?
3 feet. You want 4. 3 is tight.
Yeah.
I'd make sure that it's 4.
Yeah. So that's.
Yeah, but he's also got that brake right there too. So he's got to get 4 feet between the brake and the.
Well, I don't think I need. I just need 1 runway. I don't think I need 2. So this, yeah, this is basically
Hey,
maybe the 3.5.
hey, Dave. Here's a thought. When the rigger,
That's the back of the machine there.
Yeah.
when the rigger comes, can you have him move that brake back a little bit?
I was considering that,
Yeah, that's an
but it's
option.
kind of nestled in with the air compressor.
Oh.
You're
And,
bringing a rigger in?
well,
Well, this isn't the tape I know.
Wow. You see how big that tool is?
Oh,
yeah,
the Egyptians built pyramids.
I know. A-bomb would be disappointed in me. But I want to get it done.
And not tip it over on someone.
Yeah. Yeah, so it's like if we go, if I flip the thing around, it's easier on the riggers because the heavy,
Well,
the heavy end would be back.
you
would be
can't
back
have
here.
somebody here if you're gonna have that there. Because it can't be on the way.
It's running.
Yeah, that's
Yeah,
a good
The
point.
runway has to be over there.
Yeah, I would think so. It only has to work when the fire department inspector comes, which is once a year. But yeah, I probably should move it over.
I'm
If I-
assuming it's a
if I-
door, right?
If I cage it, then
cage
I
it.
can come in from the side.
Yeah.
We should see how that looks.
Yeah, see if you can you come in right here, this way?
Yeah, let's try that. All right, let me.
It looks like you should be able to.
Yeah, that makes a lot of sense actually.
To cut, or you're gonna have to move your robot that way.
Can't move the robot. Not very easily.
Fix it.
I'm not drilling all those holes again. All right, so let's find 10
The
feet.
real reason is you see how it's sitting on cement, there's no way to get it pulled up.
$100 tons? Wow. Oh, 100,000 pounds. Huh. Woo. Doesn't fit in the camera. Man. I'm sure this isn't cheap. And April's back there helping to scrape off the grease that comes with new machines that ship. So this is the controller. I haven't powered this up yet. I need to basically get this thing all plumbed in, and then the Haitian service person will come out and commission the machine. This is a new machine purchase. But yeah, so here's back to the operation. We got 2 injection units, and then on this side we've got this big rotary table. So this machine can overmold 2 plastics onto a single part, and what happens is the first injection unit will inject the base plastic for your part, and then the round table will, or then the mold opens completely, and then the round table will rotate 2 identical mold cavities 180 degrees, and then so what was molded on this position would now be over where April is, and then the mold closes and the second nozzle shoots the second color or the second type of plastic in, like usually either a rubber or a second color of plastic. And then the molding machine opens again, the part on that side ejects out, and then the rotary table rotates once again, and the simultaneously molded first part, substrate, then gets offered up to have its second shot molded on. And that process continues. So this table rotates 180 degrees every time, and both injection units inject their plastic. And only the second mold position ejects the part out as a completed part. And then if you look in the back here, these are the injection units. So the hopper up there, and basically this carriage moves in and out, which is terminated with this nozzle right here. Same thing as the other one. Now the front injection unit is bigger because usually your substrate plastic is going to be the larger part. And then the second shot, or the overmold injection unit, is this one back here. And it's smaller. It's about maybe 40% smaller than the first injection unit. So the idea with this molding machine is that the mold set that sits on the rotary table actually basically is almost 2 identical molds. So the B side, which rotates, has basically the same structure. The first B side and the second B side have the same profile, and that molds the substrate plastic in your 2-part plastic part. And what happens is after you inject the first shot into the mold on the B side, the left side of the mold, the whole table will rotate around, and now that substrate plastic that you molded on the B side is now, excuse me, over there on the second injection side, which has a different profile or a different shape for the second plastic. on the A side of the mold, on that side of the mold. And what happens is then the molding machine closes, and the substrate plastic that was on this side, which is now over there, gets the second plastic injection molded on top of the first, and they weld together or fuse together or interlock together if you've got mechanical inner structures that will lock the two different plastics together. And you have a little assembly line here in your molding machine of substrate molded, second shot molded, and then ejected part off. And you just keep going. So that's the idea. Now if we go and look at the clamp, this clamp is actually a mechanical clamp. Let me go around this little plastic edge here. So we're kind of inside, and you can see how there is it's basically like a toggle clamp. So and in fact it's a double toggle clamp. So this swash plate here that we see, that it gets pushed forward and back, and the result is these hinge joints pull the top kind of toggle structure down. I've got a video of this from the plastics conference, and I'll probably stick that in this video here so you can kind of see this in action. But yeah, so this clamp actually has a surprisingly small hydraulic cylinder in the back, but it's really long. There's a lot of travel, and it's all of the clamping force is mechanical advantage, basically. There's a cricket back there. So, but yeah, when this clamp fully clamps up, well, you can see right there, it says HTS 250. So it produces 250 metric tons of clamping force. And so for the people in the United States, that's approximately 280 US tons. So yeah, there's 250 metric tons holding the two halves of the mold together so that we can mold parts. So the maximum size of the part that you can mold with this is approximately the size of a sheet of paper, maybe a little bit less. So yeah, so we can really crank out some big parts on this molding machine. All right, but yeah, there's control cabinets in the front here. I need to hook the power up to this cabinet here, which has the switch that turns on and off the input power. The KUKA robot is going to work with this molding machine. Let me see if I can get this cricket out of here. Quiet, you. There's the offending cricket right there. Yeah, I see you. You gotta be quiet, I'm filming. Nope, he just jumped on me. All right, there he goes. All right, yeah, so this is the back of the machine. You can see kind of the two injection units in line, and the second shot, or the overmold injection unit, you can get a better idea of how much smaller it is. Generally speaking, it's smaller. Yeah, and then, so Big Yellow, its new job is going to be to service this molding machine with the back here. And the shop is a complete disaster because I had to move everything over for this thing to fit. But yeah, down here is the hydraulic oil chiller. So chilled water will connect there. And this is basically a heat exchanger. And then the oil tank is in here. And that almost looks like an access hatch, like if you really want to clean out the oil tank. I'll have to find out more about what that silver disc is right there. But then there's service doors in the back here, so that you can service each injection unit. And yeah, this is a hydraulic motor, like almost like a radial engine. There's like several hydraulic cylinders in there. And this is the indicator for the plunge of the plastic. So we've got 130 millimeters of plastic column in the screw auger. Up here is the actual hopper where you can turn on and off the plastic to the screw, which you may be able to see down in there. And then heaters for the injection unit are behind this protective thing. And then down here, down here is the hydraulic cylinder, which will push the the injection unit forward against the mold to inject plastic into the mold. And all sorts of just gizmos and hydraulic valves and everything else. All right, and then looking at the back, we can see the toggle clamp structure a little better. And it's pretty interesting to see it in operation. I had Big Yellow do some flyovers, so I'll stick some of that in. These holes are just access for wires and things to service your mold. This is the back side. This is the moving clamp portion, and it slides on these massive tie rods here, which basically connect to the back of the clamp. This is this big cast back clamp structure, and then those screws back there, way in the back, there's like a big gear, and basically this back portion of the clamp, this big clamp plate, moves forward and back on the big massive machine screws there, and that's how you set your mold height. And then the clamp itself, basically just this part slides on the 4 huge tie rods with big greased bearings, and this moves back and forth. So clamps up the mold, opens the mold. All of these are core pull hydraulic valves for if the mold has like sliding side pulls inside of the plastic part, then these valves will open and close portions of the mold. And also water lines for cooling the mold. And all of that has to go through the center of the rotary table on the B-side clamp. So you can see, for instance, this orange line right here, the water line, comes out through the center and then goes down to manifold connections at the bottom. So hydraulic connections up there, and compressed air, I believe. There's some air eject options, as well as cooling water and all sorts of connections, but it all has to go through the center of this rotating table. And then the ejector rods to eject your part come through this hole right here. And there's a whole myriad of grease lines everywhere just to keep everything lubricated. With these toggle clamps, there is a lot of grease points, so you gotta, that's one disadvantage with the toggle system over a hydraulic accumulator or amplifier, is that mechanical joints all need to stay lubricated. So you see all the pipework of grease connections everywhere inside of here. Then down here, this is the water cooling system for the mold. So I believe there's 12 circuits here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, there's two 12s. So 24 cooling lines here for really complicated molds. So I probably don't need nearly that many, but it's good to have. And this is the robot interface. So this connection will talk to the KUKA once I figure out all of the pinouts and the voltages and a whole lot of other stuff, which I don't want to bore you with massive details. One thing I found interesting is a lot of these hydraulic lines have these safety cables. So if the hydraulic line breaks, it won't whip the cable or the loose line all over the place. These safety cables will keep it from flying off. And there's really big ones back here. So you see this steel lanyard, which is clamped to the hydraulic hose and then to the machine itself. So if this connection blows, I'm not going to have a crazy spraying hydraulic line whipping around and whacking you in the head or anything. So that's kind of neat how they do that. So I think that's kind of it for the non-powered up tour of the new Iapetus 2-shot molding machine. 250 metric tons and 2 injection units and a rotary table. So yeah, let's get this thing running. Well, I think that'll wrap it up for this week. There's a whole lot more to do with commissioning the molding machine. I need to get the oil delivered, the hydraulic oil, and pump it into the reservoir. I need to run the power and schedule for the service guy to come out and commission the machine. We also need to load 2 molds into the molding machine And the actual first project that we're going to run on this machine will not be overmolding, but it's going to be 2 molds that are the same height that we can mold at the same time. So each mold makes 2 parts, so they're small, well, they're big. They're like 12 by 16 inches, I believe, aluminum molds, but each mold makes 2 parts. So this molding machine will be able to not run in the spinning platen configuration, but basically act as if it's 2 independent molding machines. So every time the clamp closes, we are going to shoot plastic into 2 molds simultaneously. And then when the clamp opens, those molds will eject the 4 parts out and then repeat. So basically, one of the reasons I bought this machine is that I can do twice as much parts, or in the case of these 2 family molds, I can mold 4 parts in the same amount of time it would take to mold 1 part with what we call Chewy, or the 90-ton molding machine in the other room. So we are going to get all that going. So it'll be over the next couple of weeks, but soon we're going to be running those 2 molds. And then maybe a month or 2 later, I will make the 2-shot spinning mold, and we can see how that works as well. So I hope you enjoyed the episode, and I will be seeing you next week. Please like and subscribe to the show if you'd like to see more of this machine or other projects. And I think we'll actually try to pick up a few more SpaceX launches out of the Pacific Coast down in Vandenburg Airforce Base. So keep an eye out for that. I think there's 1 or 2 around December of this year. Okay, well, I'll see you guys next week. Thanks for watching. Goodbye.